the cloud, shrink that. Open up the chat window just so I can see it. Stop scrolling. Okay, cool. Yes, and that's the answers. But here we go. So we're just going to go through this. If anyone has any questions while I'm going through it, or wants me to slow down or go over something, to say something in chat or in audio, I have the chat open on the side, so I will hear that. I will see that too. We're going to write in dark green because I'm feeling like it. So what does the Java compiler produce as output? The Java compiler, yes, bytecode. Perfect, Daniel. And if you want to say the answer too, totally valid. Also, there's like a 10 out of 10 chance that one of these questions is going to get me stuck for a second. If you see me do something wrong, also shout out. But yes, that's bytecode. Okay, what is the input provided to the Java compiler? That one is what makes the bytecode. So that's what you guys typed. That is source code. Doo-doo-doo. When is the exam? Oh God, will I get this in before the exam? That's a, you know, Jed, that is a, it's on Friday. Oh, easily. I'll get this in easily before the exam. Yeah, no, that's fine. Yeah, no, I can promise that one. That one I can do. Okay. So how do you comment multiple lines of code in Java? So a single line comment is with the, I think it's this way. Oh God, I hope it's, yeah, okay, awesome. But that's a single line. But then a multi-line, you use the same symbol, so it's gonna go using that, but you kind of break it up. So instead of slash slash, you break it up 1 slash here, 1 slash here, and then you put a star. And so now anything here, all comment. What up, Ernesto? So yeah, this is a block comment. Thank you, Ernesto. And you use, it's this symbol that we'd be looking for. So it's the do, 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 do. And what is the difference between source code and machine code? Okay, well, so source code is like the stuff that you write. That's like any programming language you write in, that's called, what you're writing itself is called the source code. I guess technically you go to a lower level language. Any higher level language like Java, C++, stuff you write there is called source code. Bytecode is unique to Java because of the virtual machine aspect of it. So your source code gets compiled to bytecode, which goes to the virtual machine. So you didn't ask about that, but I'm putting it in because it's like a middle step. And then finally, machine code is what like computers read and understand. And that one is a series of instructions represented in zeros and ones. So I'm actually, you'll learn a lot more about that in like CompOrg, computer organization, where there's technically, there's like a middle assembly language, which your source code gets compiled into. It's kind of like the bytecode in Java. But all those like the super basic instructions get turned into just long chunks of zeros and ones, and then your computer, as it processes those zeros and ones, it does something specific as it goes through all of that. So difference between source code and machine code. Source code is the stuff that you actually write. Machine code is what the computer can actually understand. So let's, while we're here, so let's go look at source code, bytecode, block counts. Awesome, perfect. Okay, so we got all that right. Let's move on to module 1. Okay. Let's get both these questions in there. What would be printed by the following code? So int a equals 12, b equals 9. So if we could write out a little thing on the side, this is really nice for that. So a equals 12, b equals 9, and then you do c equals A divided by B. So you might think 12 divided by 9 is 3 1/3, but it's not. Oh. So like 3.333. But with integers, since C is an int, you cut off that decimal. So literally whatever, and it's not 3 either, it's 1. Whoops. Yes, I told you there was going to be a chance I made a mistake. Thank you, guys. But you did 1.333. But with integers, you literally just cut off the decimal. You don't round it. So even if it was like 15, so it'd be 1.666. You just cut off the decimal. You just cut it off, gone. Get that back to 12. So C is 1, and then D equals B divided by A. B and A are still the same thing. They didn't get changed by that division. So B divided by A is 9/12, which 12 does not go into 9 at all, so it's some decimal, so it's just 0. 0 point something, I guess it'd be 0.75, but again, we just cut off that decimal place, so it's just 0. And then the system.out.println, so that's what's actually going to be printed out, this C plus D. And with this, since neither of those are strings, they're both, like if one of these was a string, then we'd have to do string addition, but neither of them are, so it's going to be 1 plus 0, so we print out 1. So 1's going to be printed out. And if we go to here, 1, awesome. Oh, don't go too far. Oh, what's happening? What the frick? There. Okay, next question. It prints out by the following. Oh, Lord have mercy. There we go. So it'll be printed out by the following code. And A equals 5, B equals 2. So we can write out the same thing as before. A equals 5, B equals 2. A times equals 5. So that's the equivalent to A equals A times 5. And remember, if there was more stuff with that 5, you can think about everything inside of that as in brackets. So it's A times all that stuff over there. So that gets completed first. But there isn't, it's just 5, so you can leave it as A times 5 like that. So it's A equals A times 5. So A equals 5. So 5 times 5 is 25. So you just replace what that's there. And it's now 25. That kind of looks like a 6, whatever. I'm going to leave it. And then here again, an A plus equals B plus plus. That is A equals A plus B plus plus. And the way B plus plus works, yes, it adds 1 to B, but it's after this gets returned. So what you can kind of think about B plus plus, it replaces that with the value of B, which at this moment is 2. And after that 2 value gets put there, so reading left to right, after that 2 value gets put there, then it adds 1 to B, but the 2's already there. So it's A equals A plus 2. So A is 25, so now it's 27. Oh yeah, and after you place the 2 there, so after you replace that B with 2, then you come over here and replace it with 3. So like that. And then we're going to go down this whole list, and we got to keep track of that plus plus concept. So, and these are just single prints, so it's not print lines, so it's just one after another. So system.out.print A plus plus. So first you replace it with 27. So it prints out 27, and then this gets increased to 28. Plus plus B is the other way around. First you change this to 4, and then you come over here and replace it with 4. So it's 27, 4, and then back over here. Again, this is 28, and then you replace this with 29. This is 28, and that's it. So it's 27428. Oh, stop jumping. I might use my mouse when I need to scroll. Yeah, that's probably easier. 27428. Okay, any questions on that? Because that can be a weird one that probably I've seen definitely that trick people up. Another good thing to note about that concept is that if there is a multiple, you read left to right and do that whole process. So I'm going to leave the A and B values as what they are. But right here, if instead of that, it was A plus equals B plus 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 B plus plus, like feels like that, you read it left to right. So first you take this 4, then erase that 5, and then you take this 5, eraser tool, there we go. Replace that 6. Does that make sense to everyone? I put the value there, which was 4, that increased B, and went left to right, so I found this one, put the value there, that increased B. So that's super important. And then this would also be A plus equals A. Here, let's make this times. If this was times instead, it would be A equals A plus 4 times 5. So make sure you get that OR's operations correct there. Or if it was like, let's say, no, even better one. If it was A times equals, and then a plus there. So now it's times plus. And so instead of A times 4 plus 5, it is now A times the result of 4 plus 5. So it's A times 9, not A times 4 plus 5. Okay. No question on that. That means people are Gucci. Gonna keep going. There's probably like a mass erase thing that I could do. That requires effort to learn. Okay. Next question. What would be printed out by the following code? A equals 5. B equals 2. Now, ternary operators, we love to see it. So ternary operators, it is this, check this thing right here. So A greater than B has the value of that A greater than B is true. So since A greater than B is true, we return the left side. So that's just B. That is just B, right? Yeah. And since it returns the left side, that means that this statement is B equals B. So B stays 2, and then print out B. So we're printing out 2. Look at that, 2. Nice. Ternary operator, woohoo. I've legit had someone say, is this a typo when looking at the ternary operator? So it's not a typo. So the colon is just part of the ternary operator. Sure, you can think of it as else. Yeah, if you think about ternaries as if else. But the ternary operator is some condition, question mark, and then something colon something. And then if this condition is true, then it returns that. If it's false, it returns that. And so this is just a part of this. You need both. Ernesto said that it's like an else. So if you think about this like an if-else statement, if condition do something and then else do something else. So this would be like this, and that would be like that, kind of. Danielle, I muted you. If you wanted to be unmuted, just unmute yourself again. There we go. Okay. Predict program output. I love predict program output. Okay, so I equals 6. Switch to modulo I, so 2 modulo I equals 2. So case 2, print 3. And if it was any of these other values, it would print out 1, 2, 3, 2, 3, or 3. So yes, because Ernesto said there's no breaks, but just if you're looking at this question and you're like, what could the possible answers be? Even if you don't know the modulo concept, like if you just had no idea what modulo did, understand that it had to be one of these 3 options, depending on if it was 0, 1, or 2. But in our case, it's the 3 option because it's 2, case 2, 3. What? Okay, there was a case 3 in here. With this right here, yes, my solution would have just added a 4 to each of these. And it's still that case right there. 3, 4. Cool. That shook me for a second. Okay. Next one. What is the output of the following code? I'm just going to call it n. N equals 20. If n is greater than 20, so we've got n, or n is less than 20. That's false. So if it's with ORs, you can just go left to right here. So 5 less than 12. That's true. So this is false or true. Does and come before order? You guys don't get to do this, but I get to since I'm not taking Java. What's the operator precedence on an and? Is it before or are they at the same time? And is before or, so we have to evaluate the and first. I misread that. Well, either way, we'll just evaluate all this. So it's 9 greater than 3, so n greater than 30 is false. So it's false, true, so that makes this whole thing false. So I'm going to erase that. So that whole thing now becomes false, and then this is false. So it's false or false. That whole thing, that makes the whole thing false. Since the whole thing's false, this doesn't go into this first if block, but there is an else there, so we print that, so false. So I vote we're printing out false. Look at that. Did that order of operations make sense? You guys have to know that. I, of course, like probably should, but I'm never going to be tested on that again in my life because they just assume that I know it. So if I'm ever confused about that, I can look it up. I also, like when I'm actually programming, if I'm worried about the order of operations, just use brackets. Brackets are so nice. Just makes everything work the way you want. Okay. So next, what is the output of the following? A equals 5, B equals 6, C equals 7. Sorry, I curved up the chat windows right there. Okay, so we've got if B is less than 2, B is not less than 2, 6 is not less than 2. So false or B greater than, I'm just going to write true here because yeah, 6 is greater than 5, so that's true. So that looks false. There we go. So false or true. So that makes this whole thing true. So we run this if statement. So A minus equals 2, and it's A equals A minus 2. So then we replace the value of A, it was 5, and now it is 3. And there's no else here. That else does not exist. So we check this next one as well. C greater than 4, that's true. So we do A minus equals 1. A equals A minus 1. And so we do 3 becomes, get the hell out, 2. And so system.out.println A, that's 2. Awesome. Does that make sense to everyone? The lack of an else, that's super important because that's one of those like, we get to trick you on these types of questions because this is things that you do to trick yourself kind of things. Okay. Is this, oh, it's a multi thing. Woo, love spreading over pages. Okay, so I'll put the following code, just gonna scroll it there. A equals 1. While that is less than 15, system.out.print that plus a space, so 1 space. If that modulo 5 equals 0, break. If that modulo 3 equals 0, plus plus continue. It's neither, it's not that or that. So we just go to here, plus equals 2. So that equals 3. And is that the whole code? I don't need to, okay, that's the whole code. Cool. So now we're just gonna go through this. So now A equals 3. It's less than 15, so we're good. So we print out another one with that space there. Modulo 5 does not equal 0. Modulo 3 does equal 0, so we do A plus plus. So that's 4. And then we do continue, which just goes to the beginning of the loop again, but it checks the condition again. So in our case, ace is now 4. System.out.println ace plus that. So it's 4. If ace modulo 5 equals 0, nope. So modulo 3 is 0, nope. Plus equals 2, 6. 6 space, nope. Yes on this one. I'll put it like a little X or something. Yeah, I'll put a little X so you know what I'm saying nope and yes to. So nope, yes, plus, continue, nope, nope, plus 2, nope, yes, plus 1. I didn't print out the 9 here. Whoops, daisy. 6, I should print out the 7 too. Whoops, there we go. I have not been printing things out. Cool. And there's spaces between all these. And then, so 10 is modulo 5 equals 0, so that breaks it. And since it's broken, the loop ends. So with the correct spacing, 4, 6, 7, 9. Go to here, scroll down. 1, 3, 4, 6, 7, 9. Oh, we do 10. I kept skipping that part. Yes, this gets checked before the if statement. I kept skipping that. That is on me. Make sure you're slower than me. I'll slow down. There you go. Okay. And that could be not multiple choice too. So if you won't you might not see the answers to be like, ooh, did I make a mistake? Okay, find the errors in the following program. Oh, I hate these. I hate these because you don't know if you caught them all yet. She loves putting these. Okay, so sum equals 8. That looks fine. Sum equals I looks fine. 4. Ooh, is that an issue with? I think it is. I'm gonna say it is. Yeah, because it's not in that scope yet. I'm gonna say that's an issue. So you need to remove the I. Oh, here, I'll put it in red so you know what issues are. There we go. So we don't want that int I. I is less than sum, I plus plus. If I modulo 2 single equals sign. So we need to make it double equals. If system.out.println 2 plus is the divisor of plus I. Also, all of these just need to become equals equals. System.out.println 3 plus is a divisor plus I, else I modulo 3, system.println 5 plus is a divisor I. Anything else y'all see? You see anything else? Like I said, I hate these questions. I would not, there's so many, it's like, oh man. Someone's screaming outside. Whatever. Okay. So if that's all we think, and that's all I think, so, you know, hopefully I'm right. You never know, though. I was already declared, should use if, should use if. Oh, and we missed semicolon. So like I said, it's so easy to fuck stuff up here. So sure. Semicolon, semicolon. Why if I modulo 2 equals 0? Oh, it's saying that's a logical error. Okay. So the other error was saying is that so a number can be like 2 can be a divisor number and 3 and 5. So like let's say 30. For 30, 2 is a divisor, 3 is a divisor, and 5 is a divisor. So you also have to read it like for what it's worth and not just syntactical errors. And even then, we miss the syntactical errors of the semicolons there. So like I said, I hate these ones. There's usually like 1 or 2 on the test. But so read the code for grammatical errors, look at your semicolons, read the code for logical errors as well. So in this case, since 2 can be a divisor and 3 and 5 could all be divisors, you don't, if with the else's here, it only checks one of them, whichever one is correct first. So like for 30, it would say that 2 is a divisor, but then not 3 or 5. And we want it to say it for all of them because that's logically what this should do since they can have the same thing. So yeah, no ifs, I was already declared, double equal sign, semicolons. Okay. Erase. Find the errors in the following. Oh, look, another one. I hate everything. Okay. Public, static, mysterious, no return type. First off, right there. In this case, there's no return statement in here. So it's, yes, Ernesto says it should be void, and that is correct. So since if there was a return statement in this body, then you would need to say, like, match the return type to the variable type. So like, let's say, like, after this for loop, it did return, if it did return X, then it would be double instead. But since there's no return whatsoever, it's void. You still have to explicitly put that. Okay, series X, double X equal, then right here in the parameter, so either this parameter need to not exist. No, this is the kind of thing where you could say either or. But so yes, it's a double declaration. It could be a double declaration. Or you could say remove parameter or remove I guess data type, remove, yeah. Or I'm just going to say remove initialization, yeah, because we don't want it to be reinitialization. And add in parameter. Honestly, The second one is longer, so I'd say I would probably just put remove parameter, but it can be or. Okay, so it equals 2. Oh, and then this would be, oh God, comma, not colon. And okay, there we go. Here, this is actually fine, except for right there. No I value initialized, maybe y? Because it's y, then that would be no infinite loop. This is a weird one. Fuck me, I'm gonna see what it says in a second. And then finally, potential infinite loop. And it just says find errors in the following code snippet, so we're not supposed to even like fix them. I think the previous one, no, it just said find as well. So I'm not even, it just says find. So let's see what it freaking says, because Jesus. Okay, so find the errors in the following code. The series method does not have a return type. X as a parameter doesn't have a data type. When J is declared, it should be separated with a comma if J is of type double. I is not initialized, and then use a comparison with the num value. Num is not declared and initialized. Oh God, there's num2. Oh my God, this was a long one. Okay, so you guys see that num was also there. I don't know why I thought it was something that was real. I is not updating the loop. Is there no way the exit loop will be an infinite loop? Yeah, okay, that was just a fuck me. I hate these types of questions. But it's good for you guys to see into and just like talk about code. So there's definitely a reason why we test it. But yeah, we got all of them except for the num one, because at that point I just written so much shit I wasn't ignoring it. But that makes sense. Oh, that was not whatever I started erasing. So okay. Can I do like whoop? No, that's a smart board thing. Isn't it? Oh, they're clear. Bless me. Clear would make sense. Okay, so module 3. More predicting the output, but this time with methods and number systems. Oh, there's a method down here. Great, love separated code. Okay, so just gonna write it here. I'm gonna call it n1 equals 4, n2 equals 9, n3 equals 18. Int res equals multi-num2 num3. So res equals down here. So this is num2 num3. So not n18. Should that work right? Yeah, 9 and 18. Oh, too far. So int answer equals var2 plus var2 times var1. So, oh my God, this is large. Okay, well, order of operations, do the multiplication first. So 9 times 18 is 90 plus 72, which is 162. 162 plus var2, so plus 18, equals 100, 780. Yeah, it's a multiple of 9, so that's fine. And then return answer, and it's, yeah, so we're not checking for errors here. Returning answer, that means res equals the 180 that gets returned. And then system.out.print res, so we're just printing out that 180 value, so I'm saying it's 180. Does that make sense to everyone? I think maybe they might try to be tricking you up with this like var1, var2. It's not num1, num2, because it's var1, var2 are set equal to what's passed in. So that var1 is set equal to num2 and var2 is set equal to num3. Yeah, okay. Clear, we discovered that, there we go. Predict the output of the following code. num1. Here, actually, I'm gonna get y'all thinking with your brains. Okay, so yeah, this is last coding question here. I am gonna have you guys do this, and how many people are in the Zoom meeting right now? Like, you don't have to be here, but I'm gonna check it with how many people. All right, there's 6 of you. No, 5 other you. So I'm gonna wait until I get, including Ernesto. So there are 6 of you. I'm gonna wait till half of you give me an answer. So I want 3 people to give me an answer. No cheating by looking at the thing. And you could just wait for one person to say the answer and then just type the same thing as they do, but try to actually work through this yourselves. Ernesto, are you thinking through it? Ernesto's in the room, so I'll type out his answer if he says something. Should I maybe do it as well? Oh, it's the same thing as the previous one, the numbers. Yeah, 4, 9, 18. That's whack. Yeah, it's very similar to the previous one. Holy crap. Okay. Oh, but it's not. Oh, yeah. No, this is a trick question. Okay. Evan, you don't have to say it. Oh, Evan. Okay, so I got one person. They DM'd it to me, so no one can copy it. So I got one. Oh, I like that, Evan. I like that. Oh, wait, no, Ernesto can cheat. I'm trying to make it. Ernesto can see the chat, so Ernesto's cheat. Did you say what your answer was, though? 11. So Ernesto says 11. Oh, wait, no, like, again, no, you don't have to type it. Evan, you had such a good idea, but I'm just fucking it up. I'm so sorry. So we got 2 answers. I need one more. We got Evan's secret answer that only me and Ernesto know, and then I gave you Ernesto's answer, but I'm not going to say it. One more, people. Oh, Danielle didn't follow it. That's fine. You're fine. Okay, so the 3 answers we have are. Get my annotation up. And if anyone has an answer that they want to say while we're working through it, that's also fine. But the 3 answers we have are 18, 18, and 11. Yeah. Okay. So working through this. And by the way, I'm saying this now. This is a trick question. But I am going to just work through what the code does just so you can see where the trick is. So, and 1 equals 4, and 2 equals 9, and 3 equals 18. And then it calls multi with num2, num3. So num2, num3 get passed to here. So num2 is 9 and num3 is 18. So it says int num3 equals num2 plus num4 divided by num2. So num4 divided by num2, that's 2. And then num2 is 9. So it's 9 plus 2 is 11. So it's int num3 equals 11. So down here, there's a num3, and that equals 11. And then return num3. So it takes this value, returns it to here. But then look, there's nothing here to catch it. So this just returns to nothing. So this function really does nothing in this case. And it's system.out.println num3. The num3 from up here is there. Because remember, these are different scopes. Squiggly brackets declare scopes. Yes, this function return does not store it into this because they are different scopes. So this num3 and this num3 are not the same. And then it's returning num3, but it's returning just makes it so that if you set something equal to multi, it would be assigned to that. So That does not work. Thank you, Evan, Danielle, and Ernesto. I will be more gracious to you in grading in the future. I'm allowed to do that. I can't just give you more points, but I can have more. Be like, ooh, I know that name. Okay. So we're gonna do the same thing. So I'm doing that now because I need some user participation. For the first, it's not gonna do for all of them. I'm just gonna do it for the last one. If you'd like to work through, that's fine. But convert the binary number to decimal. So it's gonna write it out up here. 0. Oh God, I'm drawing with the line tool. 0, 1, 1, 1. And actually, I might need more space. 0, 1, 1, 1, 0, 0, 1, 1. So that's 1, 2, 4, 8, 16, 32, 64. Oh, and the answer from the previous one, 18. We were just going based off of what I was saying correct, but it's always good to check. So yeah, 0, 1, 1, 1, 0, 0, 1. So with this right here, we can then go and just say nope and nope. So it's 64 plus 32 plus 16 plus 2 plus 1. So that is 96 plus 16 is 112 plus 2 is 114 plus 1 is 115. 115. The next one, convert 77 to a binary. Oh, convert the octal 77. Oh, the 0b, that's a great question if you don't know what that is. So the 0b is saying that the number that follows this is going to be binary. So if you do 0b and something, the number that follows should be binary. If you do 0x, I know is hexadecimal. I honestly don't know what denary and Roblox. I don't play Roblox. I don't know why that's coming up. Decimal and octal. Notation. Does it have OX anywhere in here? OX hexadecimal. Prefix, that's what it is. Octal prefix. So binary is OB, yes. An octal constant is the prefix OO. Oh, that's horrible. Is it really O? Is it really 0 O? Oh crap. Okay, so octals look like just like you could say it's either 0 prefix or front or 0 0 short because it's O for octal. That's horrible. Decimal prefix might not have one. Yeah, I don't think decimal has one. Honestly, the way I prefer to do it is, oh, I don't want to see that yet. I prefer to do, you just write your number and then down here put base 16 or number base 8 or number base 10 or number base 2. That's how I do it to say it, but we don't really care too much about that. But yeah, OB and OX are the more common ones that you'll see, and that's for binary. And so even right here, octal doesn't have a prefix. Okay, so convert the octal number 77 to binary. Obviously, there's a way you can do it where you convert the octal to decimal and then decimal to binary, but I'm going to do it the short, fun way, which is 7, 7, 7. remember octals and groups of 3. So 7 has a 4, then has a 2, and then has a 1. So that's 1, 2, 4 added together is 7. And since it's 77, they're making it real easy for you. It's 1, 1, 1. So 77 in binary is 1, 1, 1 for the first 7, and then 1, 1, 1 for the second 7. Easy. Does everyone remember that little strategy we did where octal you do 3 binary numbers? When you're going from binary to hex or binary to octal, or octal to binary or hex to binary, like whichever way you do, you can group it into 3 or 4 to go whichever way. 3 for octal, 4 for hexadecimal. Okay. Again, the last one I'm going to have you guys do, convert the decimal number 78 to binary. Oh, you're totally fine. Don't worry about it. Convert the decimal number 78 to binary, octal, and hex. Oh, I'm giving you guys the hard one. Oh, I gave you guys the hard one. Okay, so I'd personally recommend converting it to binary first. Is there a good first one? So yeah, I'd say this is going to be the long one. But convert it to binary first, and then use that binary in groups of 3 for octal, and then groups of 3 for hexadecimal. So yeah, I'm gonna have you guys say convert it to binary, and then we can do it together in octal and hexadecimal. Okay, so how many people are there now? Someone joined, I heard the ding, and yeah. So there's 7 of you. I'm still gonna say 3 people then. So 3 people, I'm gonna wait for 3 people to give me an answer to this one. It can be the same 3 if you guys wanna keep giving yourself good points in my book. But and DM me the thing if you can, and I'll keep it secret from Ernesto. I think you guys get a 4-function calculator. Oh, what are they? That's fine. I don't care. I don't care. Try you do have access to a 4-function calculator, or you should. If you don't, you still do this by hand. But I don't care if you use an online calculator. You're really just hurting yourself if you want to get through this faster. But you guys should be able to do this. So how much more of this is there? I know, I'm scrolling. I'm horrible. Oh God, coding questions. Okay, yeah, that's valid. Well, I'm only gonna have you guys answer the last one in any given section of stuff. So I guess this one I cheated by making it those 2. Okay, so I got 1 answer. Let me look at that to see if I agree with you. I agree with their answer. But only they know that. I am given another answer. Evan, did you type everything you wanted to in that? I don't know. That's fine. It's still 2 answers. It's still 2 answers. I need 1 more. And John throwing out an answer into public chat to finish us off. John, is that for the other ones as well? How rude of you. Just the binary one is all we need. Evan, still no. It's okay. We'll talk through it. Okay. True. Okay, so the numbers that I got included 1 0 0 1 1 1 0. I got a 0 1 1 1 0. I got another one of this one, so times 2. And then I got a 1, 1, 1, 0, 0. Cool. Oh, and Stuart, yeah, Stuart just pumping out. Okay, so let's do this. First off, whatever answer you get, I personally find it really easy to go from binary to decimal. You can just take it, and so like let's start with this one right here. If we just do 1, 1, 1, 0, 0, and go 1, 2, 4, 8, 16, cross, cross, 16 plus 8 is 24. 24 plus 4 is 28. So that's the decimal number of this. That's not 78. Same with this one, except it's now 0, 1. So it's 8 plus 4 is 12, plus 2 is 14. That's the decimal number of that. So that's like a quick check you can do if you're concerned if you did it right or wrong. But with that, since I now showed that this one, the bottom two are wrong, I'm going to erase them. So sorry, Evan. Love the enthusiasm. You still get brownie points. Okay, so now with this one, I am going to show 78 to here. But with, oh, we now have a 3 on this one. So with this, we go 1, 0, 0, 1, 1, 1, 0, 1, 2, 4, 3, 2, 4, 8, 16, 32, 64. So cross out, cross out, cross out. So that's 64 plus 8 is 72. Yes. 72 plus 4 is 76. 76 plus 2 is 78. So it's like a quick check. 78 is that, and that's that. So how to actually do it. The method I showed you guys, I don't know if there's another one, but it's 78 modulo 2 equals 0. 78 divided by 2 equals, what is that? 35 plus 4, 39. 39 modulo 2 equals 1. 39 divided by 2 equals in integer division. So that's what, 15 plus 4, 19? 19 modulo 2 equals 1. 19 divided by 2 equals 9. 9 modulo 2 equals 1. 9 divided by 2 equals 8 divided by 2 is 4. 4 divided by 2 equal a modulo 2, I guess, first. 0. 4 divided by 2 is 2. 2 modulo 2 equals 0. 2 divided by 2 equals 1. 1 modulo 2 equals 1. 1 divided by 2 equals 0, and we stop. So now we stop there. We just go in reverse. So it's 1. So cross that out. 1, not that. 0, not the division. 0, not the division. 1, not the division. 1, not the division. 1, not the division. 0. So that's the method I showed you guys. I don't care what method you use as long as you get the right answer. But with this method, it's the modulo divide, and then you go in reverse, ignoring all divisions, taking the digit and putting it in your number. Okay, so confirmed. That is the number. It's 1. Yeah, okay, I got it in my head. 1, 0, 0, 1, 1, 1, 0. So that's the number. Now let's convert it to octal. Groups of 3, starting from the right side, 0, 1, 1, space, 1, 0, 0, space, 1, 0, 0. So from here, you just convert each of these binary numbers into their octal equivalent, just the 3. So again, the order would be 1, 2, 4. So 4 plus 2 is 6. 1 is 1. 1 is 1. 116. So a couple of you guys sent that out. That's the octal number. Now in groups of 4, you do 0, 1, 1, 1, space 0, 0, 1, 0. And then remember it's 1, 2, 4, 8. 8 plus 4 is 12, plus 2 is 16. 8 plus 2, yes, that's correct. 6, no. 14, I can count. 14, 14 in hexadecimal. Counting on my little fingers, you go A, B, C, D, E. So 14 in hexadecimal is E. Because remember, 10 starts at A, so you just go 10, 11, 12, 13, 14. A, B, C, D, E. So E. And then right here, the last one is just 1, 2, 3, so 4. So 4E. Did someone else send 4E? I think someone did. Yeah, 4E. That looks right. Go check it. Oh, and look, there's the notation I like. So make sure you put the notation if it's a free response. So it was 111 and 2, and then 116 and 8, and then 4E in hexadecimal. So since that's in the answer there, make sure you put it in your official answer here. Just remember to do that in the test. Okay, so we spent a hot minute on that, but numeric conversion is important. You're going to need it for like the future lab. But so I'm going to go back to just doing them until we get the last one in this section in this module. So predict the output of the following program. And 1, and this is a double, but that's integer division. So even though it's stored in a double, that's still integer division, and I might be proved wrong by this. If someone would like to say that I'm wrong, go ahead. We'll figure it out in just a second. Bring the chat back up. So N1, I say, is going to be 8. And 1, I say here, again, integer, oh yeah, this is a check on if you know when things happen. So I'm going to say this is also integer division. Oh, this is N2 now. N3, I'm going to say here, N3 is not integer division because this double, so right here, this is straight integer division. Here, it's casting a double, but it does this first. So it's doubling the already divided stuff. So it's still integer division. Here, it's saying make 17 a double. So now that 17 is a double, now this is no longer integer division. So 17 divided by 2 is 8.5. And then here, this is definitely fine. So N4 is easily, that's definitely not integer division. That one is also 8.5. That's what I'm saying. I could be wrong. We're going to find out in a little bit. So yeah, just printing out straight in this order. So I say it's 8, 8, 8.5, 8.5. Am I correct? I hope I am. Oh, let's go. So did that logic make sense to everyone, what I said? This first one should be no question. This last one should be no question. It's well, if you do have a question, we can still answer it. But in my head, the first and last one, no question. It's these two middle ones that might be a little weird. The first one is saying cast to a double what's right here. Because since this is in brackets, it does that first. So basically, it holds the cast and it holds this value, and then it casts that value to a double. But this value right here, the 17 divided by 2, since both of those are integer at the time of division, it's 8. This one down here, however, since there's no brackets, it doubles, it casts 17 to a double first, and then it does the double 17 divided by 2, and that's no longer integer division. Cool. What is the output of the following program? Public static string, so string 1, I'm going to call it S1 equals hello. S2 equals world. S3 equals string 2. So S3 equals string 2. I'm fairly certain. Oh God, this one's going to be, oh, I hate everything. Do strings do what they need to do? I'm going to hope that it's a different one. String 2 equals world, or string 3 equals world. And then string 2 here, doesn't change anything. Oh, but I guess it's setting it to a new one. Oh God, okay. This looks like a trick question to me, and I'm about to fuck it up. But string 2 gets set equal to world. It was already set equal to world, but now it's just a new world. And then string 1 equals string 2. We got a D in the chat. I can't believe I just said that. And so S1 is equal to S2, so it's printing out S1 plus S3. And world. I agree it's D. This looks like a trick question though. But it was not. Okay. Cool. Yes, I agree it is D because it was world. What is the output of the following program? So we got this enumeration right here. Love enumerators. I don't think we ever talked about them, but she probably definitely went over them. Public static void main string. So level is the enumeration, so that's valid. Level myvar, so I'm gonna call it MV, equals level dot second. So it's equal to that level dot second. So I'm just gonna call it second. Or just sec, sure, that's fine. And then system.out.print myvar. Oh, it's asking what enumerations print out. I'm gonna say it prints out just second. I think it just prints out second. This is a syntactical question of how do enumerations work. So I could very well be wrong about that, but you really just have to memorize it. Easily enough. Got it. Okay, I still have some knowledge in me. So even though it's set equal to level dot second, that's still just second. It's saying the second from level. So it's still just second when you print it out. Okay. If you have questions about it, I'll happily answer, but I'm fairly certain that really just boils down to you need to remember how enumerations work and how they're stored. And it stores just the variable second. And that's not a string or anything. One thing to note, this isn't a string. So if you did like if myvar equals to in strings second, that wouldn't work. We can test it if you want to test out other examples and stuff. That's the kind of thing that's really easy to test out in programming. So we could just open up IntelliJ and test stuff out. Love to do that. Happily do that with you guys. Okay. What is the output of the following program? Oh, there's a little else down there. Gotta love it. So we have C1 equals A, C2 equals C, C3 equals E, and lower and uppercase are different. So this is uppercase, lowercase. If C1 equals character.to uppercase A, system.printout, is it 1? So that's true because this turns it to uppercase and that's equal to that. So that is true. So it will print out this. If C2 is greater than C3, so C2 greater than C3, the way the alphabet works in the ASCII system, if you guys have never seen it, is that you don't need to know what the values are. You just need to know that A is lower than Z and capital A is lower than capital Z, that kind of thing. I don't think they're going to ever ask you relative lowercase to capital, but if it does pop up, I'm fairly certain lowercase is lower than uppercase. Oh, no, I was wrong. Let's see, here's the ASCII table. So I'm gonna oh God, what did I do? Just gonna move it over there. So here's the ASCII table. And so each character, oh, that's a horrible pink. That's also not the best. I'm just gonna pick blue, sure. That's good. So each character has an associated decimal value. And so A is lower than Z. And so it goes in incrementing order. So B is 1 higher than A, C is 2 higher than A, D is 3 higher than A. So just understand that value recognition. And then I don't think we're going to ask it, but you could now note that lowercase a is actually higher than uppercase a. You definitely don't need to know the relative values. We'll give you an ASCII table if you need to know that. But I don't think we've even talked about ASCII tables yet. But just know that relative relationship, that that a is lower than z. And it'd probably be a good idea to know that lowercase a is higher than uppercase a. And then also same thing with numbers. 0 is less than 9, but it's sequential. Also know that the character 0 does not equal the decimal value of 0. So that's another good one to note. You don't need to know what the value is, but just know that it's not the decimal value 0. Okay, let's go back. Okay, so C1, C2, C3. So if C2 greater than C1, C is less than E. So this is not true. So that's not a thing. We don't print out though, no, because that's just not a thing. And then else cisna enta or 11. I don't know what or 11 is, but sure. But that does print out. So this checked out because 2 uppercase A is equal to this uppercase A. And then this was false, so it did this else right here. So this is true. So I say is it 1 question mark space or 11 question mark. That's what I'm going to say it is. Right there. Awesome. No questions, keeping it going. What is the difference between instance method and a static method? List 3 of each one. You guys know about instance methods there yet? I mean, invoking object. Fuck me, what? Invoking object doesn't need an invoking object. Access to member. What does it fucking mean by? Wait, did it say list 3 examples? Oh. Wait, what? Those are different questions. So I guess you know instance and stuff. Okay. Well, they didn't give an answer for that one because it's different, but I guess I'll just pull some shit out my ass. So, and I guess you guys know instance and static in this context. So, instance methods are, so it's 3 things. I'm not going to write out everything I say, but it's 3 things. So the first one I'm going to say is that instance, I'm writing it out, whatever. I'm not going to write it out. You guys can write it out if you want to. That's a lot. But yeah, instance methods are associated with an object. So that's the first one. Instance methods are associated with an object, and static methods are not. Oh wait, no, it's not 3. Oh, got it. So it's what is the difference between an instance method and a static method? So the difference is that instance methods are associated with an object and static methods are not. So that'd be like if you have so like if you have int x equals 5 and then you do, that's a bad one. What one do I know you guys know? You guys have used strings, maybe? No. You guys have done 3 labs so far. We haven't really talked about non-instance stuff, and it would be in strings where you'd first see it. I'm trying to think of just any. Okay, whatever. I'm just going to go with it. So strings are an easy one. And I think that's why they used it for both the examples there. String x equals hello. And so strings have a substring method. So you do x dot substring, or there's like maybe 2 capital or something. String to uppercase Java. Oh yeah, 2 uppercase is good. Oh, and it even shows it right there. Perfect. So as you can see here, this text, it's saying string text equals hello world, and then text.to uppercase. And here, actually, I can fuck with stuff here. So I'm going to do that and then the same thing. Oh, semicolons. How I love you so. There you go. It's TXT I can spell. Evan, thank you for DMing that to me. Like, let's not call Steven out. You can, yeah, that's fine. Okay, so there we go. So I guess I kind of want a little bit of both then. I guess it doesn't do what I wanted it to do, but it's fine. Still good to show. I guess it's not universal, so you can, whatever. Here we go. So text.to uppercase. Text is a string object. So string object text. And so we do a string object dot to uppercase. So this function, this method, sorry, it's function in C++. This method is associated with a string object. So you can call this on any string object, but it has to be a string object. So that's an instance method. So this is an instance of a string, and you can call methods on instances of strings. A non-instance method, I'm just going to use this environment now because I can, and it's going to fuck me up. If we did int x equals 5, I don't know why I'm writing it here. System.out.println. If this fucks up, I'm just going to open IntelliJ. Integer.to string x. This isn't going to work. I know myself too well. Let's do that plus 10. So it should be 510. Okay, awesome. So here we have this integer object. So it's int 5 equals x. But right here, we don't do x.toString. My mic broke. There we go. Does that work now? Yeah, cool. Dope. I think I might have just muted myself. Who knows? Okay. Oh, no. Share screen. Okay. So here, we make this int object, but this function right here, we don't say x.toString. Like we tried to run this, it would be an error. Even like that, I don't think that exists. So we don't do the object.toString. We do integer .toString. So this function, while associated with this class, it's not associated with an object specifically. Because this function, it takes parameters, but the parameters don't count when it comes to instance or static methods. Yeah. So what this does, it turns x into a string, so it's 5 strings. So 5 plus 10, since 5 is a string now, it combines them like that. But since this isn't an instance of an integer, it's just integer itself .toString. This is a static method. So if we go here, it says, what's the difference between an instance method and a static method? Remember, instance method, you do it like an int object dot something or a string object dot something. So that's like variable names and stuff. Static, you do the class name dot something. So it'd be if you did string dot something or integer dot something. 3 examples of each one. I'm just going to give you the 2 and the thing. I'm not going to try to think of 3 because that would take me for a hot minute. But so it's string dot value of 5, static, A, B, C, D, E, and length. Oh my God, I'm an idiot. I could have done length. So right here, this string is this whole string here, and that you have a string object. So this could be, if you had done like string var equals A, B, C, D, E in quotes, and then done var dot length, that would have been fine. Same thing here. It's a string object itself dot character at. That's another instance. And then again, double. It's not any variable. That's a keyword. That's a class name dot parse double. And it takes parameters, but the parameters don't dictate whether it's static or instance or not. Okay, awesome. Love those types of questions. Testing me on my remembering stuff. I'm so good at those. Okay. So now on to here. Annotate again. Awesome. Okay. What is the output of the following program? Plug static void main string name equals. That was the LE. I'm just gonna put G there. And then string S name equals empty. It's not even a space. It's just empty. For int I equals 0, I is less than name dot length I plus plus. So name dot length. If name dot character at I equals, that's a space character, continue. So since we're starting at I equals 0, that's just going one by one through here. So right now we're going to start with A. Since it's not that, it's not a dot. So S name equals S name plus name dot character at I. So S name equals A. And now it's L. That's neither of those things. L. Spaces continue, so you don't include that. E, not either of those things we do. Dot, not a space, but it is a dot, so that breaks. So we break to here. And so now print it out S name, print it out is ALE. ALE. Or is it A1? No, that's an L. That kind of looks like a 1. Whatever. If on a free response question you put 1 instead of L, that's if it's like something like that, that's a not. I won't worry. Okay, awesome. Question 7, last one on this, so you guys get to do it again. And hopefully this one's a fun one. So yeah, given the following code, predict the value of var1 and var2, public static void there. Num1 equals 3, num2 equals 8, Boolean var. Oh, that's holy crap. Oh yeah, you guys get to do this one. It's not super hard. Just remember your order of operations. Remember that you do things in the order of operations, like those pluses, do them like whichever direction they are. Again, there's 7 of you total, so I'm gonna wait for 3 of you to do it. And so you need to tell me what var1 and var2 are. DM me in the chat when you get an answer. I know Danielle's been answering a lot, and then Evan. You can keep answering if you answered before. I'm just scrolling through now, looking at the good noodles. And you can always be a good noodle. Don't let your past define you. Try to answer the question. I take wrong answers. And if you DM it to me, no one will know it's your wrong answer. Oh, Evan, no cheating. You gotta give me both of them at the same time. Because, yeah, both of them at the same time. And this is a good thing to note just for the future in these kind of things. You want to wait until you're done with all of it to give you an answer, because let's say maybe var1 was an int instead. So if it was like int var1, and then in var2 it was like plus plus here. And so that could change the value of var1 after the line where var1 was initialized. So things can change as they go through, and so you want to give the answer at the end. And Evan, if you have an answer for var2, so if it hits shift, enter, and send, you got to send it as well. Oh, but you were typing it into the chat as your, oh, that makes sense. That makes sense. So we've got a half an answer. And then what do you think var1 is? What's var1? And var2? Okay, so we got two answers now. Ernesto's giving me one, and Evan's giving me one. Come on. Also, don't rush it. So like if you're working on it and we get to the end, keep working. Don't feel bad like if it takes you too long. Technically in the test it is timed, but it's plenty of time. You guys have a test on Friday. I don't even know when my next test for my class is. I have no clue. I'm just about to start scrolling on my phone. Ooh, John pulling in with the third answer. Check my emails for a second. Okay, so it looks like everyone has the same answer. So that's either great or sad. We'll find out in just a second. I don't know what the answers are, gonna be honest. So the three things that I got were v1 equals false and v2 equals 11. So working through this, Danielle got the same 4 people, killing it. Okay, so we got Boolean var1 equals not num1 plus, and it's plus plus first, so n1 3 and 2 equals 8. So it's plus plus first, so it's 4 greater than equal to 3. That's true, not, that's false. So liking it so far. Int var2 equals var1 question mark, so that's false. So it runs this side of the code and returns it, so none of that. So num1 plus plus, so it's 4, and then makes it 5. Plus num2, but it's minus minus first, so this is 7. 4 plus 7 equals 11. So var2 equals 11. I agree. Let's go look. False 11. Awesome. Great job, guys. That kind of question, I definitely have, like, people get tricked up on that a lot. And it's usually like 5 variables and not 2. So I'm really glad y'all got that. Good shit all around. Okay, so now we're on to coding questions. Coding questions are unique in that, like, there's definitely many ways to do them. One thing that would be good is that when you see a question, just think about all the functions that would be useful somewhere in it potentially. So I'm not going to write out a whole solution for each of them unless someone wants me to specifically go over one. But I will write through some functions that when I first see it, I'm like, ooh, this would probably be useful. And so maybe some like if I want a for loop in there or something. So implement your own version of the built-in substring method of the Java library. The function header for the substring method is as follows. This method returns a new string that's a substring of the string s. The substring begins with the character at the specified index. So it's string beginning index. It extends up to end index -1. Note, only write the method and any helper methods. No need to create a class. You are allowed to use substring method from the Java library. Oh, you're not allowed. Yeah, okay, that makes way more sense. You're not allowed to use the substring method from the Java library, but feel free to use functions such as character at and length. So yeah, anything goes except for substring. Do not write a class. Just write this method plus any other methods you want to write if you want to write more. So you definitely, like, your solution should just have this in it, like, and that's what's required. If you want to write another method, that's fine. But then the things that I think would be useful, probably like a for loop. That's the loop you're probably going to want to use with these values. Index -1 begins with the character at the specified index and goes index -1. So use that in your for loop. So it's these, I guess, technically. They say specifically even down here, character at and length. So length would be good for your for loop as well. Character would be like inside of your for loop. It returns a string. So make sure at some point in your thing you do like string, like it's some variable. I like to use toReturn just to remind myself, but it could be anything. You could call it like var1 or just var or whatever. And then eventually return var. Like a string has to be returned. I think anything else. Yeah, with the for loop, character at length. I don't think I would write any helper functions for that. Yeah, no, because it's just it really could be done like a single for loop with this, but cannot use substring. Okay, for 2, write a method identical digits into num that takes an integer num in the range of 10 to 90. This method doesn't return anything. It prints out a count up starting from the integer num and stops when both integers are identical. So note, for coding simplicity, follow each output by a space, even the last one. You will assume num value is always in the range of 10. There's no invalid number passed in. So we're saying this explicitly. You do not need to do if num less than 10 or greater than 90, like return or break or whatever. Don't need to do that. Good thing to note is just through reading this. So write a method identical digits int num. So you do identical digits int num, and then it takes an integer num. You already have that in there. This method doesn't return anything, so it's void. And that's it. So that's the requirement right there. That's all you need. I probably would put static, but that's not required. The required part is that, because that's what we told you in, it was that method, and then it doesn't return anything. Okay. So key thing to note there, remember, no main, no scanner. I didn't say scanner for the previous one either, but no scanner. We're printing out stuff, so you do need system.out.println in there. Counting up, so you'll do num plus equals 1 or num plus plus or something to increment num by 1 somewhere in there. I probably would use a for loop. So that num, that plus plus would be here. And then your condition be like, you could do like num divided by 10 does not equal num modulo 10. Something like that would be really good. Yeah, division and modulo are super important in this kind of thing to get those 2 digits, because we're only working with those 2. So super important there. That's really, honestly, this is the big part for this kind of thing, because 10 to 90 you're only working with 2 digits. So the num divided by 10, that gets you the tens digit, and num modulo 10 gets you the ones digit. So that's super important for that. Understanding how division and modulo can get you digits is super, super important. And actually, if you did like, so this might be something that's on the test. I honestly don't know what's on the test. If you did num equals num modulo 10, that would cut off the ones digit. So if it was like 127 here, this would now make it 12. So if you put this thing in a kind of loop, that could break down each of the digits. Make it smaller and smaller. That, like, I could easily see something like that coming up. Cool. Clear it. As long as there are questions, I'm going to keep continuing. Write a method. Print triangle. What? That takes in a positive integer base and prints out a triangle made out of asterisks with the base of the given size. My first thought for this is a nested for loop. So you could have for I equals 0, I less than the passed in number, and then obviously plus plus. And then in the nested one, you could have for j equals 0. Oh, no, j equals I. That's what I was going for. J equals I, and actually start this one at 1. And then this one, less than equal to base. Yeah. And so you have this less than equal to I. I'm going to scroll down just so it's a little easier. Have that. And then in here, and then this is, no, hold on. 0, and then while j is less than I. I know semicolons look like j's, so shush. And then in here, you could add the system.out. That'd be super easy. Does everyone see why this works? Because it print i's 1, j's 0, prints out 1 star. I's 2, j's 0, j's 1, stops. I's 2, j is 0, j is 1. No, 3. So yeah. 1, j 0, 2, j 0, j 1, 3, j 0, j 1, j 2, 4, j 0, j 1, j 2, j 3. What? Oh, okay. Well, that kind of thing's easy. So once you have that, then just like this isn't it's like I said, this is just like scribbling down some notes, but to get a new line after it, you just like right here. So once this for loop goes through, it does this system.out.println line, and then it restarts the whole thing. Does that make sense? And this could not work. We're not testing it. Like I said, I'm not going to test it. I'm just throwing out some stuff. But this one is, it's 2 for loops and then the print out stuff would make it pretty quick. Okay, that prints the same triangle above this with the base at the top. So it'll be the same thing as before. I'll leave this to you guys, but it's the same thing as before. But now you wouldn't start I at 0. You would start I at base. So you'd start I at 5 instead of 1. And then you do minus minus instead of plus plus, but similar concept. Oh, this is it. Write a method to convert a positive decimal number to octal string representation. The function header is as follows. So this goes into the way that I say to do things. Like I'm not even going to show this one at all. The way that I say to do things. So a positive decimal number into octal. So if you have like 1, 5, 8, 7. Remember, my method is the number divided by 8. Modulo 8 equals something, and then 1, 5, 8, 7 divided by 8 equals something. And I say do this in integer division, and then you just keep doing that process over and over again, whatever this result is, and then start over again until you get division divided by 8 equals 0. That is perfect for a loop. That, like, incorporating that into a loop is what that is made for. Like, that's why I like it, is because for this kind of problem. So it would be with the method that I talked to you guys about with the modulo division repeated until division gets you 0. And you put that probably inside of a while loop. That'd be perfect. And then, like I said, as you go through it, like you just start with a string, and then you do like var. And so you do var plus equals the division part. No, modulo part, the modulo part. No, it would be other way. No, so yeah, not plus equals. It'd be var equals modulo part plus var. Yeah, that's so the modulo part plus var. It'd be something like that. Because yeah, the first one you do is the far right digit, so it would keep adding on to the left side. That's how you add to the left side. Cool. Okay. What time are we at? 11:21. Yeah, we're fine. Last but not least, a prime number is a whole number greater than 1, which is only divisible by 1 in itself. Write a method to detect whether a number is prime or not. So that kind of thing, a for loop would be great. And then using if statements, you could do modulo. So just a for loop. I equals, you want to start at 1. Actually, you'd want to start at 2. Yeah. Yes. And then I less than n plus I, or I plus whatever you want. And then if n modulo I equals 0, return false. And then if that for loop goes through, so if that for loop goes through, then return true. Does that make sense? Because this is checking to see modulo gives you a remainder. And so if something modulo number has a remainder of 0, that means that it's a multiple. So if n modulo I gives you 0, that means n is a multiple of I. And while I is less than n, so once we don't check when I is equal to n, if any number less than n modulo n is equal to 0, then it doesn't work. Technically, there are ways to make this more efficient. but this works. More efficient ways would be like I is like you probably want to divide n as you go or subtract. I don't know. There's probably more ways to make it efficient, but this is like a straightforward one. Is there any concepts that we talked about in the coding stuff? Because like I said, I don't know what the questions are. I just want to give you guys some of like the things you want to think about. So like this is like a for loop. This one in my head works with a while loop because you don't know how long that's going to be. For loop, nested for loops, when I see like two things looping and so looping every line and then looping across each of the row. So anytime I see like an array kind of thing, a 2D array. Identical numbers, counting a certain amount of times. This could be a while loop on it. Yeah, this could be a while loop, not gonna lie, but definitely some sort of loop. Lots of loops in coding stuff. We usually have like one loop, but sometimes there isn't. If there's no questions, I think we have like 10 minutes left. I don't know what I'm gonna do for 10 minutes, but I'll be here. Oh, we only got 5 minutes left, so yeah. Not much left to discuss. I'll go back to any questions if you'd like. Yeah, with that, we're done. I'm gonna stop recording.